Let's see. Okay, awesome. Yeah, so my name is Elijah Polofsky. I'm from New Mexico Tech in the US. And yeah, let's get into it. So, so actually, let's see real quick. Something. There we go. Okay, so identifying cybersecurity discussions in online open forums, especially in a scalable manner, is of great interest to identifying modern cyber threats. However, doing that sort of detection at scale is tricky for two reasons. The first obstacle is that it needs to be scalable. It needs to be very, very scalable. It also, of course, needs to be quite accurate. So the goal of this research is to create it's an English text natural language processing tool for classifying text as being either cybersecurity related or not cybersecurity related. In order to accomplish this, the methods that we use to gather the training data are that we use specific open forums online that sort of have inherent labeling capabilities built in to pull labeled data. We use three different text sources. The first is Reddit. So Reddit sort of inherently will classify text or posts into specific focused discussion forums. These are called subreddits. So we can restrict what subreddits we look at to pull a specific text. There is, of course, noise in this process, but it allows us to get a really, really large amount of high accuracy labeled data. The second forum that we look at is Stack Exchange. So Stack Exchange is a developer forum. There is, of course, cybersecurity discussion there, but most of the discussion there is not explicitly about cybersecurity. It's more about something like, coding implementation. And so there, that adding that forum as training data allows us to be able to differentiate between just, developer-focused discussions and something that is really specifically about, say, a security vulnerability. And there, Stack Exchange provides specific topic labels for both the commenter, the poster, and people who reply to add topic labels to that discussion, so we can restrict searches based on topic labels. The last forum that we look at is arXiv. So arXiv is an online repository for posting preprint research, and that's definitely more of an academic focused source of natural language. But there again, we can sort of restrict our searches to specific cybersecurity keywords or non-cybersecurity keywords, and there again, there's specific topic categorization that we can pull data from. And so this table is showing the total number of documents that we pulled from each of these sources, as well as the two classes, cybersecurity and non-cybersecurity. Okay, and then we pre-process this text using word tokenization. So here, this reduces the size of our data set a little bit from the previous slide, just because some of the quote unquote documents might be empty or not have any detectable English words. Yeah, so here's a distribution of what some of the document word lengths look like as in histogram form. So Stack Exchange is on the top left, Reddit is on the top right, and arXiv is on the bottom. Those x-axes are the total number of effectively words that we count in those documents. Importantly, these three distributions are pretty different. So for example, the Reddit source is typically a very short post. Something that's on the order of just a couple of words, as opposed to arXiv, where that's a full a research paper that's on the order of thousands of words. So the vectorization method that we use is term frequency inverse document frequency. We used an English dictionary that had about 25,000 unique words in it. And we trained 7 different machine learning models on these 3 different text sources. So the 7 machine learning models were decision tree, random forest, logistic classifier, linear SVC, multi-layer perceptron. And then we also implemented a TensorFlow deep neural network with tens of thousands of nodes and trained to 2 different levels of accuracy. So overall, we got 7 different machine learning models for each of the 3 text sources. That's an overall 21 trained models. And I'll go into some of that training here in a second, but at the end of this, we combined all 21 of these models into an ensemble tool where we can make a final decision about a particular text document using the majority vote of these models. So this is an example of one of the training models that we did, which was for the deep neural network. We trained just until we reached a training accuracy of, in this case, is 0.95, so we didn't overfit it too much. And this table 4, is showing the original training accuracy that we get from training on each of these separate sources, and then the cross-validation accuracy. So what this means is if we train on, in this case, 1/2 of the Reddit data set that we have, we can then validate on the other half of the Reddit data set that's unseen. And there we get some false negative and false positive rate. We can also then take that model and see its validation accuracy on, say, the archive data set or the Stack Exchange data set. And so on the rightmost 2 columns there, the false negative and false positive rates are shown. And we repeat this for all of the models that we trained. Here's the table for the logistic model. Here, a similar result. Importantly, the false negative and false positive rates do vary by quite a bit. For example, here, when we trained on the Reddit model and then we classified on the Stack Exchange model, we got basically a 50% false negative rate, which is pretty terrible. What that means is that the idea, like what the model that trained on Reddit data, it's sort of a model of what cybersecurity discussions are, do not map well to Stack Exchange. And that tends to make sense. The reason is because Stack Exchange is just generally more focused on technology and coding and that sort of stuff, whereas Reddit is much more like popular culture. So you might have trained on Reddit getting much more, say, I don't know, coding implementations or something like that, whereas Stack Exchange is entirely that. So basically these 3 models contribute something pretty different to the idea of what a cybersecurity discussion is. And that's part of the reason that we looked at combining these models into an ensemble decision-making system. So yeah, so what we do is we classify, say, you know, a group of documents that we want to determine which of these documents are talking about cybersecurity. We train, or we predict using all 21 of these models whether each document is cybersecurity related or not. And then we just use majority vote on those 21 models to make a final decision. And this final tool is written in Python 3. It uses multiprocessing where applicable to make things more scalable. And so the next step is to characterize this ensemble of models using some completely different unseen data sets. In this case, we use something called AG News and a philosophy text data set as being definitely not cybersecurity, and then we hand label some cybersecurity text. And then we just run on this entirely new text. So to be clear, just to repeat, this text that we do these validation experiments on are not from Archive, Reddit, or Stack Exchange. They're entirely disparate sources, just because our models were originally trained on those 3 sources. So here first we're showing the false negative rate for all of the 21 models. as well as, so on the left-hand most side is the CTC tool, the majority vote of all of those models. And what we see is that basically most of the models are performing worse than the ensemble of all 21 models. But some are performing a little bit better in terms of false negative rates. Okay, and then if we go to false positive rates, what we see is that the models that did have a really low false negative rate now have a high false positive rate. So let me go back to false negatives very quickly. So what this shows is that overall, using the ensemble decision of these 21 models gives a lower overall error rate. So the sum of false negative and false positive rates is lower with the CTC tool as compared to any of the individual models. So for example here, so we're looking at false positives. If we look at Stack Exchange random forest model, it's basically a 0 false positive rate. Okay, but then if we go over to the false negative rate, it has an extremely high false negative rate. Okay, so overall, the ensemble of these models performs best, sort of trading off between false negatives and false positives. Okay, and then the other important thing that we want to look at is because we want to use this tool to classify text, what's the scalability of this, right? Can we run this on something like hundreds of thousands of documents? If so, roughly how much time does it take? And the answer is yes, we definitely can. The limitation is essentially just the memory, the RAM on the machine, because it has to load in so many documents at once. But it can batch process definitely up to about 500,000 input documents. And the scaling is roughly linear. Again, this is using multiprocessing. And the training and validation text, if you want to use it, is here at this GitHub link. So in conclusion, we trained these 21 distinct models using 3 very disparate text sources. We combined these models into a consensus voting tool. And the characteristics of this tool are that it is scalable and accurate, which are the goals that we wanted to achieve for this type of tool. Future work would be to consider unsupervised clustering methods to determine how close, say, an input document is to be used in training. Sorry about that. As well as gathering data from other online text sources. And possibly also using other vectorization algorithms to make use of a larger dictionary of words. And also possibly translating non-English words to be used in these types of data sets. And another interesting avenue would be to analyze the explainability of these types of machine learning algorithms. In particular, something like decision tree might be able to tell us what specific words indicate a cybersecurity discussion in this type of online forum. And yeah, here's my contact email if you have any questions. And here are the references. Yeah, any questions?
Thank you.